Good afternoon, everybody. Good morning for some, I think. Liz, you're TAing today, correct?
Yeah, I'm leading the lecture, if that's, yep.
Awesome. Just double checking. All right, well, I think you can go ahead and get started. I don't have any announcements or reminders at this time.
Okay.
Thank you.
Yep, no problem. Okay, let me go ahead. I'm going to share my screen. So what are we doing today? So it's week 2-2 is a session. We're going to be working on the pipe operator. Thank goodness we are learning the pipe operator. It makes everything easier. And then more data manipulation. So before we get started with that, does anybody have questions? With a reminder that there is going to be a new question and answer session on Friday. So if it's a very specific question, like something's not working on your computer, it's probably best that you go to that session on Friday. But if you have specific questions about what we covered on Tuesday, we can do that now, or just jump right into the pipe operator.
Really quick before you get started, Liz, I just wanted to address something that I saw in some of the feedback we were getting. I know I did post your script on our Teams page because people were asking about notes, but I wanted to let everyone know that, while someone is going through the training, you should be having that like Learn Basic R week 2-2, whatever, up. And that is basically the notes, like that will explain like what each function does. Yes, I know it's hard to write them down while you're in the middle of the training, like in the script, but you have that to reference like as you're going through or when you're reviewing later on your own time to like, okay, this function means this line did this, because it's all right there. So hopefully that should help address some of the notes issues, because we are providing a lot of information for you guys on the Teams page. And I know not everyone uses Teams, but considering there's 80 people that signed up for this training, we wanted to keep all of our resources in one spot. So if you're having trouble with the Teams page still, please talk to Jesse, or you might need to talk to your agency IT. But we are providing a lot of resources through Teams just to prevent the constant emailing. So just wanted to make that quick housekeeping note.
Okay, great. Okay, so the other thing is I thought I would try, I know several people, we've gotten numerous suggestions about volunteers typing notes as they're writing script. And I personally, I think that's too much to ask of a volunteer, especially someone that's new to coding. And I'd like the volunteering part. And I think most of the TAs, and probably Min would agree with me, to be as accessible as possible, so that people feel comfortable volunteering. So I thought what I would do today to sort of give people a flavor of what that might look like is that I will do the first section, and I will write notes as I go. So hopefully that will slow me down. I still make mistakes, so hopefully I make some mistakes. And we'll see how that goes. And then for the next sort of part of today's session, so that would be starting after we talk about filter. So for the functions summarize and group by, I still want to ask for a volunteer. So you have a while to think about that. And I think it's a good idea to, not everybody learns the same way. And I think that some people probably prefer having a volunteer do all of the coding. But we've never had someone who has more R experience doing the coding. So we can try that, and I will try and go at a reasonable pace and write notes. And so we'll see how that works just as an experiment. But I don't want to lock in any of my fellow TAs who may be doing lectures or Min into doing what I'm going to try and do today. So again, just an experiment to see how this goes.
Thanks for
Okay.
doing that, Liz. Well, I'll keep an eye on the chat for you.
Okay, thank you. Because and if you could interrupt me, Jessica, if there's something that I should really address that's in the chat right away, then I will. I think that might be better because the chat gets kind of wild.
Yeah, no. Myself and the other
Okay.
TAs will manage the chat, and I'll let you know if anyone's like, hey, slow down or something.
Yeah. Okay. So hopefully you have RStudio up. And so the first step is to open a script file. So we'll just review how to do that. It's Control-Shift-N on your keyboard if you prefer keyboard shortcuts. Or we can go over into the menu and open up an R script file. We can save that. I like to click on the little save icon if you would like to. And just name it whatever you want to name it. Okay. So hopefully you all have a script window open. So the first step is we're going to load packages for today's session. So library, again, is the function to call packages. So we're going to go ahead and call tidyverse all at once. So you type tidyverse inside of those parentheses, and then to run the script in the console, you press Control-Enter on your keyboard, and you wait a little bit, and then what you should be seeing is attaching core tidyverse packages, and then it will name all of those packages and what versions have just been loaded. So last session, we really used dplyr, so dplyr. And I should also note, which I didn't last time, is that RStudio has generated cheat sheets for many of these packages. And so you can, for instance, I've printed out the one for dplyr, ggplot2, lubridate, and readr. Those are probably the most common ones that I end up using. And those, if you just Google like tidyverse cheat sheets or RStudio cheat sheets, it's going to come up. And those can be very handy to refer to until you've memorized everything. So let me actually, I'll just put a note in here. Google RStudio cheat sheets has dplyr, ggplot2, lubridate, and readr at the very least. Okay. So the, oh, and I should also say that it's kind of written in these packages when it needs to mask or hide a function that has the same name. So that's kind of what that's about. So let's go ahead and load the rest of the packages that we've been working with. So library janitor is another package, and Control-Enter. And you'll see some text feedback in the console from that. Library data.table, and Control-Enter. And you'll see some text feedback when you type that one in. And then let's also do library read Excel. Okay, that one was probably already loaded, or it doesn't have any text feedback when it was loaded. Open XLSX. Control-Enter. Okay, so we've got all of our packages loaded for today. any questions so far in the chat, Jess, or should I keep going?
You can keep going. No questions so far.
Okay. All right. So the first example that Min has for us is she has this menu of comparisons. And comparisons are really important for the functions that we're going to be using. So comparisons are important for many of the tidying functions. Okay, so she has some examples, and a lot of them you're familiar with because you've learned them in math at some point. So greater than, or equal to, less than, or equal to. And then the equal to in R is actually a double equals sign. So I should probably just show this. So the double equal sign, and then not equal to is an exclamation point and an equal sign together. And then to find a value in a list, you use this symbol. So a percent and then the letters IN and then a percent. And then personally, one that I find tremendously helpful is is.na. So is the value missing in that, for instance, that column? And then the converse of that, the exclamation point is.na, which is like a double negative, but finding all the values that don't have NA. And then another one is string. It's str is not short for structure in this case. It's short for string. String underscore detect is for looking in a column for a specific word. So that can be really helpful when you have a lot of factors. For instance, in like PM 2.5 speciation data, when you've got all these elements, you could search a column to find an element. And then there are a bunch of examples of what happens when you compare things. So I think we can go ahead and just do this one right now because it'll give you a feel for that. So what I find helpful is actually to type it up in here. So it means 4 does not equal 5. Is that true or false? And so when you run it, this is what you get. So that's true. 4 does not equal 5. So let's go ahead and put this in as a reminder. So does 4 equal 4? So again, we use the double equals sign. So double equals sign means equal. Is it true or false? Okay, so we know what the answer to that one is. It's, of course, it's true, but the main point is to learn that you don't just type in an equals sign, you type in a double equals. Okay, 4 less than 3, so we should see false. Oops, space. And as I'm running these, I'm running Control Enter, so it is false. 4 is 4 greater than any of these in this list? 1, 3, or 5. So R is very iterative, however you say that. So is 4 greater than 1? False. Is 4 greater than 3? False. And then is 4 greater, oh, sorry. Haha, backwards. True. True and false. I'm left-handed. My brain works backwards. pardon me. So yes, 4 is greater than 1 and 3, but it is not greater than 5. So when you're asking R to do these comparisons, and you've got a string of values, it's going to go through each one of those values and give you an output. So it's not exactly what you would expect. Like, you know, it's not going to give you, yes, 4 is greater than 2 of the values, or it just evaluates it on a true versus false basis because it's only a logical, so it's true or false. Okay, next example is 5. Does 5 equal any of these values in the string? So this one is, we predict is going to be false, false, and true. And that's what we see in the console. The next one to try is 5. Is that is there a 5 in the list? Okay. So again, the one above, does 5 equal any of these in the list? You get a value for each, a false, and a true. It evaluates that. Now we have something slightly different. It says that is 5 in that list? So what we see is yes, 5 is in the list. So it gives you a single value. So when you're writing sort of these comparisons and you want it to evaluate, say, a value in a column, you want to make sure that you're using the right logical request. Okay, so 2% in 1, 3, and 5. This is going to be false. Okay, and then the last is 2. Does 2 equal NA? And I think we all know that's not going to work. Control Enter. So when that happens, it doesn't return true. It doesn't return false like you would think, okay, true or false. It'll actually just return NA. Because Min has it written down in the notes that, and I can retype it here, missing values are regarded as non-comparable. Comparable even to themselves. So comparisons involving NA will always result in NA. Okay. So we've covered that exercise. The next thing I'm so excited about, we get to work on the pipe operator. So that's the next thing. And this is extremely useful, especially if you're going to use the tidyverse packages. So the keyboard shortcut for pipe, which is this, is Control, Shift, and then M. You can change these keyboard shortcuts. There's a way to do that. And if we have time at the end, I can show you. I actually had someone help me initially when I was first learning R, and he preferred a different keyboard setup. So my keyboard shortcut for the pipe operator is different than the default. So why use the pipe operator? So the reason to use a pipe operator is to create readable code. Okay. So Min provides an example in her notes of, say, old school R coding. And some people, their brains work this way and they prefer that, and that's just fine. But most people do not find nesting functions to be highly readable, unless you are used to it and you read sort of from inside out. So we'll give an example of a nested function. And you go parentheses crazy. So if you have trouble tracking your parentheses, or you inadvertently make keyboard mistakes, this can drive people crazy. So it's basically saying take the sum of these values, then take the log of the sum of those values, and then please round that log of the sum of those values. So we'll go ahead and run that in the console, and we get the answer 5. So this is really difficult for people to read. I think the easier way to do this, and Min has the example written for us, is to first use the pipe operator to separate these lines. So you would type in the values that you want the operations to occur on. And so the data frame version of this is that instead of writing C parentheses 10, 20, 30, 50, you would write the name of the data frame, say air quality. And then you would insert the pipe operator. So for most people, that shortcut is Control-Shift-M. And then you can go to the next line and write sum. And you don't have to do anything. You don't have to retype the data frame or the values. You just have to write in the function, because the pipe operator just kind of works through the functions as they're listed. So you want to take the sum first, then the log, and then finally you want to round the values. So what you have eventually, just get this higher up. It's annoying. So eventually what you have is this. So I think this is far more readable. It's also easier to modify. So if you decide to change one of the functions, or you want to reuse the code, but say you want to filter it differently, or you want to create a new column with mutate like we learned last session, all you have to do is come in here and edit a single line, versus using nested code. Then you go parentheses crazy. And I think a lot of times what people end up doing is rewriting the entire section of code, because the parentheses are so hard to keep track of. And RStudio does help with that, but I think also remembering that a lot of us may be writing code and sharing it with people who are not that familiar with R, and so this is a much easier way to do this. So I'm going to go ahead and write, press Control-Enter. Oopsies. Control-Enter. There we go. So let me scroll up here. So you can see the code with the pipe operators gave us the same value as the nested code. Okay. All right. So we're going to start using the pipe operator on the examples that we did for last time. So just to remind everybody, let's see the first six rows of the air quality data frame with column names. So we can call head on air quality. And we can see here down in the console that it's printed out the names and everything. So generally when I'm working with data, and this is also in Min's example, is when you start manipulating that data set, I rename it as a new object in R. And so what that does is it preserves the original data, and it's the equivalent of, say, creating a new worksheet in Excel. So say typically if you put your raw data, if you're working with raw data, even if you're working with QA data that you've exported out of AQS, you would put your raw data in sheet 1 and maybe name it raw data. And then in sheet 2, you would then start putting in equations. Yeah, that's the Excel word for it. I've completely flipped to R, so sometimes I've lost my Excel literacy. But anyway, so we're going to go ahead and do that. So we're going to create a new data frame name because we are changing the data. Okay. And then we're going to refer to the the raw data that we want to make a change with. So that's air quality. Okay, and refer to the original data. Okay, and then after air quality, we're gonna use the pipe. So you can go ahead and put the pipe in, and then typically what I would do is just hit enter, but that's gonna screw up my notes. X. Okay, and so like we did last time, we want to go ahead and use select, and we want to select the ozone month and day columns. But actually, I've gotten tired of typing in capital and lowercase. So I'm going to go ahead and type in clean names from the janitor package, which is going to lower all of those. So I want ozone lowercase month and day. Okay. I'm going to go ahead and run that code. And then I want to check the data frame air quality new and make sure I did that right. So the ozone month and day columns are now all lowercase. And we did that with the clean names function. Okay. So again, just as a reminder, the clean names function, it's not only going to make those names lowercase, but it's also going to tidy them up. So if there are letters and numbers kind of smushed together or maybe separated with a period, it's going to change all of that to separation with an underscore and lowercase. Okay. Yeah. Okay. And perhaps I also want to arrange this new data set, and I want to show the highest ozone values first. So I'm going to add in a pipe operator, and I'm going to say arrange. And then I want to, instead of seeing the ozone values go from lowest to highest, where I would just type in ozone, I want to see it highest to lowest. So then I type in descend function, and inside of the descend function or descending function, I type in the column name. So arranges the ozone values from greatest to least, or greatest to lowest in the data frame. Okay, so I can go ahead and run that. So we can see over here, we've just got a mishmash of values. So 41, 36, 12, 18. So we're going to go ahead and run this again. And then we'll run Glimpse again on the same thing. And now we can see that the ozone values are actually ordered. So that we can see them from greatest to lowest. All right. So now that we've done that with our data frame, the next step that we have is to create that new column. So instead, we just put in the pipe operator, and we use the function mutate. And we type in the new column name and then what value we want in the new column name. So here it's inside of mutate function, new column name, and then the value. For text values, they need to be in double quotation marks. Okay. Okay. So now we've got them all piped together. So when we go to actually run this data and change the air quality data frame, it's one command. So it's just Control Enter. It runs all of the code. You can see that in the console. And that way, if you need to go back, and let's say you decide, I don't want to just narrow the columns down. Let's say I want to look at all the columns. Then you could run it again, and you've deleted that select statement, and take a glimpse, and now you've got all of the columns back with tidy names. So that's just an example of how you can quickly edit your code. And if you want to put select back in, you can do that.
Hey, Liz, really quick.
Yeah.
Some folks in the chat wanted to see the remainder of your notes for, I think, mutate, whichever ones kind of go off the screen a little bit when you get a sec.
Yeah. Thank you.
Thanks.
Yeah, let me also do this. Okay. Yeah, you wouldn't typically want your notes like this because it makes it hard to edit the code, but yeah, because thank you for saying that. Okay, these people can't see it as I write it. Duh. Okay, so we're going to go through the filter function. I use filter all the time, but filter, I have learned it it can behave in ways that you wouldn't necessarily predict if you aren't very accustomed with filter. So we're going to go through some additional examples, but let's first just introduce the filter function. So let's say I want to filter the data for the month of August. And this is in MIN's week 2.2-2 curriculum. So I'm actually going to name a new data frame so that I can remind myself that this is just August. Now, you don't want to do this too many times, I think, based on personal experience, because then you've got a ton of different copies. It's like having 50 worksheets in Excel that you have to keep track of. And so I think there's a way to optimize your code once you kind of have everything written so that you're not managing tons of different worksheets or versions of the data frame. But anyway, we're going to start here. Let's go ahead and use what we've already created, which is air quality new. And we're going to put the pipe operator in. And then we're going to filter that data set for August. So we are lucky that when you go down here and you look at the month, it's in an integer format. And they're all numbers instead of text. And in many ways, that makes it easy because numbers are less prone to human mistakes. For instance, let's say someone was entering the data and they used August as all lowercase, and then someone else entered some data, and now you've got an uppercase A and lowercase the rest of the word, or you've got a misspelling in the word. And so one way to check that if you have that situation, and we'll go up here, is to actually use unique. So Min covered this function. So unique, what you can do is say, I want to know exactly which months are in the month column. So I reference the data frame first. So air quality new. Then I use the $sign to indicate I want to look at a specific column. And then I type in the column name and I press Control Enter. And what this gives you is the unique values that are in that column. So the data set basically covers May, June, July, August, and September. And that way you can also check, say, if these were text names, do you have August all in lowercase or not? Okay, so I digressed. All right, so we're going to filter for August. So we're just going to type in the letter 8. We're going to check. We can go ahead and use Glimpse to look at the beginning of the data set. August. Okay. But we can also use unique again. So let's just verify, since we did a filter on a single column. In fact, I don't even need to retype this. I'll just go back up here and I'm going to double check. Air quality new. So that was the previous data set. Sorry. This is why I'm saying be careful how many times you rename stuff. We want air quality August. Control Enter. Now we have successfully filtered it down to the month of August. So in fact, to make to make this even clearer, I will go back and re-edit it. Okay. So this is a way to verify that the filter worked correctly on the month column. It's not so easy when you start using more filters, but we'll get to that. Okay. So then let's say you don't want to look at May. You're primarily, something happened in May, maybe too many sites were down, or you know, there was a major issue, so you want to drop May. So the way to drop May would be air quality No May. We'll work with the new. So again, we don't want May. We just want to exclude May. So we're going to use the exclamation point and the equal sign and type in 5. And then do this. We'll just glimpse it. So there, you can see that there's no 5s in recent history. If you wanted to be absolutely sure, you could call unique again. And we want air quality, no May, and we want to check the month column. And so we go ahead and do that, and we can see that we have successfully dropped May. Okay. All right. So the last thing is filtering on multiple conditions. And this is the one I think once you're pretty confident using the different logical conditions, so equals equals, exclamation point equal, greater than, less than, the one that you find things in list, so the percent in, percent. Once you're confident in how those behave, when you start adding in multiple conditions, you want to be careful in how that you write them. Because filter, you may not have filter working the way you think you have it working. So let's create another one, air quality in August, and we only want to look at the high ozone days. Okay. We're going to use the air quality new again. And I'm sorry, I typed in the wrong operator. We want the assignment there, and we want the pipe here. Air quality new. And then we're going to use filter again. And we're going to filter first. We're going to say ozone, we want that greater than or equal to 70 when there's an exceedance. And then we want month equals to 8 for August. And we can go ahead and run that code. And then let's just use glimpse. August high ozone days. And so you can see it picked out all of the days. In a small data set, Glimpse is very useful. You can do this. If you didn't have such a small data set, what you could use is View, as long as it isn't like super gigantic. But since you're filtering, usually you're decreasing the size of the data set. So that can also work. So you can go ahead and use View, and some people are more comfortable with that. And R is nice. It actually already ranks them for you. Okay. All right, so the comma. So the thing to pay attention to in here is the comma. So in general, the comma equals the logical command of and, otherwise known as the funky ampersand sign. Okay, and then the other logical that operates in filter is or, and or is the pipe sign. So let's go ahead and do an example. So let's say we decided we wanted to look at August and September. That's all we wanted to see. So we go ahead and filter again, but this time we're going to say we want the month of 8. So we want August, and we also want the month of September. What the heck's? So in our language brains, we say we want the month to be August or September. But sometimes we say and. We want both. We want August and September. So if we were to write it just like that, it's not going to work. Because R is not, doesn't operate on the English language. It operates on math. And so what we're really saying is we want to find the column. In fact, I'm just going to edit this up here. Or better yet, I'm getting lazy. I'm tired of typing. We want any column that has the value 8 or 9. Okay. So instead, we're going to use the pipe. We're going to run the code again. And then I'm going to reuse this line. Oh, now it worked. So we have a column that has either 8s or 9s in it. And if you don't believe me or you don't believe R and you want to double check, you can. And we successfully filtered it to 8 or 9. So this is just one example of how you need to be very careful when you're typing in these statements in R for the filter function. And I know I'm like super late, but that's just the way it is. Okay, so we are now going to filter for high ozone days on 2 conditions. So when you're doing 2 conditions, what you're saying is, okay, I want ozone, greater than 70, and I want the month to be, I want all those values to be from August. Sorry, my English is going out the window.
Hey, Liz, just a quick note. A few minutes ago, someone was asking if the pace could slow down just a bit, if possible.
Okay, so that's fine, but we're not going to get through the rest of the lesson. And that's okay. I'm sorry, whoever has to go next, that I didn't finish it all, but I can try and go a little bit slower. So to provide, okay, let me go back. If I'm going too fast, I need to go back. Okay, so we covered the comma. So the comma kind of equals the logical command of and we looked at how that worked. We then decided we wanted August and September in our data set, and we used that, and that did not work. So let me go ahead and, this did not work. Do not use. Okay, so in order to get it to work, we need the pipe the pipe symbol means or, and successfully limited the data set to just August and September. this is the code to double check that the filter function worked as expected on the data set. Specifically, the month column. And let me go ahead and define air quality underscore August underscore September is the data frame. The $sign refers to a column, and month is the column to operate the function up. Okay. All right, I think I'm going to stop there and check for questions before I keep going.
Not many in the chat. Basically, there was one person asking what that symbol, the pipe symbol basically, and I said that it pretty much means or, if you want to think of it as like a word.
Yep. Yeah. Okay. So I think at this point I will summarize. I don't think there's enough time to get a volunteer set up to start coding. So I will summarize. So this is probably a good comparison. So Tuesday we did the session with 2 volunteers and just someone leading 2 volunteers through. And then this is kind of what a session would probably be if you had one of us coding and writing notes at the same time, if they were willing to do that. Okay, so we'll go through summarize. I don't use summarize a lot. I would probably, yeah, I don't use summarize a lot. I use it occasionally. So summarize is a good way to add in descriptive statistics. So mean, median, mode, minimum, maximum. So if you want to very quickly find those values in a data set, summarize can be really useful. So we're going to talk about summarize. And we're just going to show an example of finding the average ozone in the air quality data set. Okay, so I'm going to say summarized air quality. And I'm going to use the air quality new because I know that has the clean names. And then I'm going to put in the pipe operator. Then I'm going to type in the function name for summarize, and it will accept the rest of the world's version of summarize or British English. So because remember, R was written in New Zealand primarily initially, so summarize will work as well. So if you see that, it's the same function, just a different spelling, because they accommodated all of us American English speakers. So summarize, and then we want to define sort of a column, and we'll say ozone average equal to the mean of the ozone column. Okay, so we'll go ahead and run that. And then we can go ahead and print that actually right in the console. The way to do that is you just type in the name of the object. You wouldn't want to do this with a huge data set. And of course, I just hit enter and not control enter. Okay, so it spit back NA. We know that's not right. So the thing about using mean and some of these functions is that you can't have any NA values in your column of interest, so in the ozone column. So instead, you need to put in an additional argument. So in order to do that, I'm going to retype this. You could just copy and paste, or you could edit the code above. Ozone average equals the mean of ozone. And then we want to tell R to remove the NA values so that it can generate an average for that column. So we wouldn't always want to do this, but for the purposes of generating a mean, that's okay. And so the argument for that is NA.RM, which just means remove the NAs. And you want to say equal to, you can write in T for true, or you can just write in the whole word. It doesn't matter. And then you can go ahead and run that code and print it again by doing Control Enter in the console. Did I do that right? Summarize ozone average, air quality new. The hex? Is it not working? Oh, no, that's not the mistake I made. I wonder if it doesn't work well with the pipe.
Hey Liz.
Yeah.
NA.remove is inside the main function. Do you see that? It's outside your parenthesis. It's the second argument of your main
Yeah.
function.
Thank you.
Yeah, sure.
Mean of ozone summarize. Oh.
Yes, so I don't know if everyone just saw what happened, but basically Liz needed to move the NA true into the mean function. So that way it's doing it when you're calculating the mean. Sorry, just wanted to add that.
Yep, no problem. So here's how not to make my mistake. I see, this is why I don't use summarize a lot. And so, all right, so this is the mistake way. So before, what I did here was I went outside. I actually was outside the function. That's the wrong way to type it. This is the correct way to type it. And that's why it wasn't working. Okay. All right, and so then we can add in an additional one as Min has written in here. So let's see if I can get this one right. Temp underscore sum equals sum of temp NA.RM equal to true. And there you have the ozone average and the sum of all the temperatures. Okay. I am at 2 o'clock. I am going to stop there.
Thank you so much, Liz. I know it was tough with the time, but I really appreciate what you did. I hope this was helpful for people. I know this was a lot of information, but again, we are starting the office hours tomorrow at 1. These will be every Friday. And also all these meetings are recorded and they are in the Teams folder if you need to review these later. Definitely review the GitHub page that has all the steps. I think that will help you guys a lot if you feel like you didn't quite get everything during this training. So thanks again to Liz for leading this week. I know it was a lot, but you did great. And we'll see everyone next week.
Thank you.